Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of Geography Unplugged, we're going to be discussing about one of the most important as well as scary forces that we'll ever come up against. And the natural disaster that we're looking at is earthquakes. So earthquakes are some of the most potent disasters that are occurring around the world. And so therefore it is best to learn about them and so be on guard against them. So first of all, what is an earthquake? So an earthquake, which is also called as a tremor, is the shaking of the surface of the earth resulting from a sudden release of energy in the earth's crust, that is the lithosphere. So when the earth's crust starts to move, it creates waves which release energy, and then this energy release will shake the earth, and then the shaking of the earth causes much of the infrastructure that we have to fall down and get destroyed. So earthquakes usually occur at faults. These are areas where earthquakes are highly to be occurred, and there are three types of faults that slide against each other, which are known as strike slip. So diagram A shows a strike slip fault, and then B shows the normal fault. In a normal fault, one of the plates go above and the other goes below, and so there is rubbing between the upward and downward motion of both the plates. In a reverse slip, one of the plates go above, and then it forms a sort of ledge, and then the other heavier plate goes down. So these are the most common types of faults that we can see around the world. Now, we know what an earthquake is, but what causes an earthquake? Well, to understand this, we need to think of the earth as an onion. An onion has many layers, and similarly, the earth has many layers as well. So the earth has four major layers: the inner core, which is solid, the outer core, which is molten, the mantle, and the crust. The crust and the top part of the mantle, they make up a very thin skin on the surface of the earth. But the problem is, this skin is not all in one piece. So it's made out of many pieces of land that covered the earth like a jigsaw puzzle, and these pieces unfortunately keep slowly moving around. They slide past each other and bump into each other, and we call these puzzle pieces of land tectonic plates. And the edges of these plates are what we call plate boundaries or faults. The plate boundaries are made up of many faults, and most of the earthquakes around the world occur on these faults. Since the edges of the plates are rough, they get stuck while the rest of the plate starts moving. Finally, when the plate has moved far enough, the edges unstick on some of the faults, and there is an earthquake that occurs because of the release of tremendous energy. So this visual shows us how one plate slides through another, and then because of that sliding, there is release of energy suddenly, which causes an earthquake. By the way, this happens under an ocean. These can also happen on land and also on water. It depends on the plates and the plate boundaries. Now, how do we quantitatively measure how earthquakes are recorded? So earthquakes are recorded by instruments that we call seismographs, and the recording that they make is called a seismogram. Now, the seismograph is basically a bob which is attached to a base that is set firmly on the ground, and the heavy weight that is on it hangs free. When you have an earthquake, the base, which is connected to the earth, shakes, but the heavy bob, because of inertia, does not shake. So therefore, the shaking of the base causes the heavy bob to start recording these patterns on the paper, and the difference in position between the shaking part of the seismograph and the motionless part is what gets recorded as an earthquake. Now, these can be interpreted in various scales. One of the common scales that we use is the Richter scale, which measures earthquakes from 0 to 9, basically. So earthquakes that are rated 9 are extremely dangerous, and according to the rate, the severity of the earthquake changes as well. Now, Earthquakes occur under the surface of the Earth, and we've had various breakthroughs in technology in, measuring earthquakes, etc. But using this technology, can we predict earthquakes? No, not exactly. It's unlikely that we will ever be able to predict earthquakes. Scientists have tried many ways of predicting earthquakes, but none of them are successful so far. Now, the way that scientists currently predict earthquakes is that they look at the various fault lines, and there are some fault lines on the Earth which are particularly active, so they always keep high alert in these areas, and the other areas are under a low alert. So on any particular fault, scientists know that there will be another earthquake sometime in the near future or the far future, but they have no way of telling when and where it can happen. Now, how do we find out where an earthquake actually occurred? Well, the epicenter is the place from which the seismic waves start propagating. So we use a method called triangulation in order to locate an earthquake. So we have seismometers in three areas, so there are many seismometers around the world. And suppose an earthquake occurs in one place. The nearest seismometers, 3 of those, will, publish a reading, and then we find out the distance between the earthquake's area as well as the seismograph, and then we draw a circle on the map, and then using these circles we find out an intersection point for all the 3 circles for the 3 seismograms, and then that area, that point, is what we call the earthquake epicenter. So this is how we use triangulation. The seismometers are shown here as green dots. The calculated distance from each seismometer to the earthquake is shown as a circle. The location where all the circles intersect is the location of the earthquake epicenter. So, these are technical terms regarding earthquakes, but if you want to visually experience what an earthquake is like, we've got some clips showing the severity of an earthquake. So that's why we keep telling that earthquakes are dangerous, and by seeing these videos you would know why. So that concludes this video. We hope you take precautions against earthquakes. You can always learn more online. And if you want to access more of our useful and interesting content, don't forget to subscribe to our channel, which is Blitz Audios. So until the next episode, take care, stay safe, bye-bye for now.